In Chabba Niwada Microgrid implementation, we have installed 70 kW solar PV, a hybrid inverter with 100 kWh of battery energy storage system and AC-DC-AC converter for power sharing. Now, we will be explaining the different modes of operation of the Chabba Niwada Microgrid. If the grid power supply is available, the load of the Chabba Niwada will be supplied by the available solar PV generation. If there is more load in Chabba Niwada, exceeding the PV generation, it will be checked by the microgrid controller whether there is a surplus of power in the neighbor village Bargadia Purva. If this is the case, the surplus of energy will be supplied to Chabba Niwada via the AC-DC-AC converter controlled by the microgrid controller. If there is still more load in Chabba Niwada, then the battery storage will be utilized by the microgrid controller. If PV generation, battery storage, and a possible power import via the AC-DC-AC converter from Bargadia Purva do not cover the load of Chabba Niwada, the grid power will be utilized. If the microgrid controller detects that the PV solar generation exceeds the demand of Chabba Niwada, the microgrid controller will charge the battery system of Chabba Niwada with this excess of solar PV generation. If the battery storage system of Chabba Niwada is fully charged and there is still excess solar energy, it will be verified by the microgrid controller whether there is a lack of energy at the neighboring village hamlet Bargadia Purva. If this is the case, the AC-DC-AC converter between both villages will be utilized to export energy from Chabba Niwada to Bargadia Purva. If the battery storage system of Chabba Niwada is fully charged and there is no lack of energy at the neighbor village hamlet Bargadia Purva, the remaining excess solar energy of Chabba Niwada will be exported to the grid. If the load of Chabba Niwada exceeds the solar generation, the remaining power will be supplied by the battery storage system, as long as the energy storage system contains enough energy capacities. In order to keep the frequency and voltage of the microgrid within the foreseen limits, the PV string inverters will discharge power to the loads. In case of any deficit, the battery will be discharged to loads, with PV priority. If there is more load within Chabba Niwada exceeding both the solar and battery discharge, then the possibility of importing power from the adjacent hamlet would be devised by the microgrid controller. If the load of Chabba Niwada exceeds the solar generation and the energy storage systems run out of energy, the microgrid controller will send a command to the storage system to go into sleep mode. And therewith the storage system will be disconnected in order to keep some energy for a later restart of the system. The PV inverters will trip in this case because they have no grid forming ability. If the solar generation exceeds the load of Chabba Niwada, the energy storage system of Chabba Niwada will be charged. If the solar generation exceeds the load of Chabba Niwada and the energy storage system of Chabba Niwada is nearly fully charged, it will be checked by the microgrid controller whether this surplus of energy can be utilized by the AC-DC-AC converter for the village hamlet Bargadia Purva. If this is the case, as much as power, up to 25 kW will be transferred via the AC-DC-AC converter to Bargadia Purva in order to balance the demand and generation to Chabba Niwada. In case there is no grid supply and the microgrid of Chabba Niwada was down due to a lack of power for the microgrid controller regularly checks whether the PV generation potential increases. If the solar generation potential rises, the energy storage system will be switched on in order to perform a black start. By re-establishing the foreseen frequency and voltage levels, the PV inverter will switch on and charge the storage system.